look at an introduction to GitLab as a platform, really. So, for those of you who may be using GitLab currently for purely SCM or SEM and maybe CI/CD, that's great. Some of you may not be using it at all. So this is really just to kind of give you an introduction to where we're coming from, why we do what we do, and the reason why things like DevOps and DevSecOps platforms have just become important over the last few years. So let's cast our minds back 17 years, if you can, to look at the kind of landscape around different technologies, different tools, different services to provide things like music, to tell the time, to have a calendar, to have a diary, to take photos as a phone, etc. We had a number of different things that existed there in the world, and they weren't really necessarily linked up particularly well. And we had a few things, or more than one things to manage, which is obviously time consuming. So what happened 17 years ago is that we saw the smartphone come along. And what the smartphone allowed us to do is really embed a whole load of different functionalities on one platform. So, on your phone, on one interface, one single pane of glass, in an integrated way, we could get our phone, we can have our camera, we can have our emails, whatever weather sites we wanted to go to, text messaging, etc., telling the time and all that kind of stuff like that. Now, this is kind of linking across to where we currently are today with today's software delivery landscape. So we've had a number of different evolutions of DevOps and DevOps tooling. Originally, it was, continuous delivery CI, which is made up of a number of different products that do different things. So we call them point solutions for things like security, for basic SCM version control, for CI/CD, for build automation pipelines, etc., for monitoring applications in production. So this is where a lot of organizations find themselves today. Where GitLab is coming from is that we're trying to mitigate some negative aspects that come from having a number of different tools that we have to maintain. So with this toolchain sprawl, there is a need to integrate these products, to have some kind of integration between them, especially if we want some kind of reporting metrics about how well we're doing. It's difficult to do potentially collaboration between different tools, and we end up with just this landscape of a number of different tools that we're weaving together. We are putting together teams that whose sole purpose is to look after these kind of integrations, and arguably those people should be spent elsewhere, potentially writing business critical or useful applications. And also in terms of dealing with the landscape itself, there's an increase in cost, there's an increase in time also spent with looking after the vendor companies who are actually providing these things. So there's licensing, there's version control stuff, but between different license versions and version management, etc. So a lot of companies find themselves in that space today. Where GitLab is coming from is that we believe, in the same way that the smartphone enabled all these different functionalities to exist on a single platform, we believe that there are different stages across the SDLC, DevSecOps cycle that we can integrate onto a single platform. Everything from basic source code management, CI/CD, security scanning, compliance rules automation, package registries, container image registries, all those different functionalities, release management functions, environment configuration, etc., should be in one location. And it's not really just us saying that. There are also partner organizations, there are analyst organizations when we talk about things like DevSecOps platforms, and customers that we speak to that very much believe that moving this into one location is an important move for them for all the reasons that I've specified before. So that's the kind of reason why we move forward as GitLab as a platform. We very much look upon ourselves as a DevSecOps platform. We're constantly evolving, adding new functionality and improving on the functionalities that we have in there right now. So one of the features that we have within GitLab, within our plan stage, if you like, is the ability to manage projects. So we can do all the things that a typical PM function would do, project management, create issues, do all the things that we need to do with that. So this section really is tasked with looking at project management within inside the product itself. And what we'll do is we'll have a look at the different ways in which we can structure our work within inside GitLab from an organizational perspective, and how we actually measure things over time, and how we can do typical PM functions such as that. So within GitLab, we have the concepts of groups. We also have the concept of subgroups, and we have the concept of projects within inside those groups. So a typical way to think about this would be a group being a line of business, a subgroup within inside that group being a team within inside that line of business, and the project, all of which hopefully you're looking at one now with the Tanuki Racing app, is the place really where the work is done, if you like. So this is our repository. This is where we define our CI/CD rules, and we define other things as well. So this is where teams work. We collaborate, we plan, and we write our code, and we deliver our applications from our projects. Tied in with this, I will touch on this at a very high level here, is the fact that we have we can assign users to groups, and so we can have hierarchies of different users going down through our group and subgroup hierarchies down to our projects. So we can configure what certain users are allowed and not allowed to do within certain groups and projects. So that's the kind of way in which we organize our work within inside GitLab. The way in which we define our work from a project management perspective involves using some concepts that may be familiar to some of you who are using existing tools to do things like agile project management, but we have all the usual suspects like epics and issues and sub-epics, etc. So let's just touch a bit more on what those look like. So epics are really, if we think about high level features, goals, strategic initiatives, that are really placeholders and containers for issues. So we can place a number of different issues from a number of different projects into an epic. What we can also do is place sub-epics into epics. So we can even have, if we can break our pieces of work down into something a bit more granular, but still contains a number of different issues to actually complete that piece of work, then we can place that into a sub-epic if we want to as well. So issues really they're important to us, as we'll see in the workshop coming up, as we'll see in the hands-on session. But we can describe small discrete pieces of work, typically things like use cases, pieces of functionality, etc. What we can do with issues is map those across into our world to things like merge requests when we want to make changes as part of those issues. And as a subsection of issues, we have tasks, and with inside tasks, these are really a way of breaking down into different steps how to complete a given issue. So issues can be, as it says here, building new products, fixing bugs, or doing whatever we need to do. Typically, the issue is the start point for pretty much everything in our world. And we can get the ball rolling with some issues, and you will be creating an issue as part of the lab coming up. When we talk about tracking work, so we've organized work, we've defined work. When we track work, we're really thinking about, how can we track something occurring over time? So, and there's different ways in which we can do that inside our world. Roadmaps, iterations, and milestones are the way forward. So we can define roadmaps where we can put, display epics and have them with some kind of temporal basis where we can see how our epics are performing over time. We then go down to the kind of iteration level where we can track issues that we define over small periods of time. And this is more in line with the kind of agile sprint methodology or mindset, and then milestones, which is a broader phase of time where we can track issues and merge requests against a set period of time at our group and subgroup and our project level. So that's how we track work. We can do things like, put start date, end dates in. With iterations, we can put iteration cadences and define those, which are specifying, how often do we actually want this? How long do we want this iteration to last for? And then under the covers, GitLab's smart enough to move issues and jobs across to the next iteration if we don't actually make it into this particular one. Let's just move forward from this. This slide here really gives us a visualization of really the organization definition and tracking side of things. So on the left here, this is a hierarchy, groups, subgroups, and projects, with the project being the place where the work is done. When we're defining work within epics, we're defining these capabilities. Epics contain issues. We can have sub-epics. And then inside sub-epics, we can have other issues as well. And when we are tracing these things and tracking these things, we can use roadmaps at the group level, milestones and iterations. And then we can also have roadmaps down at our subgroup level for various things, sub-epics. And then we can also define project milestones within inside the project itself. So for those of you who are doing agile tools, agile PM management right now, these are the things that we can use, and they probably map similarly across to things that you are doing and using right now. So let me just take a pause there for a moment before we get into the lab. I'm going to take you through what we're going to be doing in the first lab here. Just bear with me for a second. And what we are going to do is, in my group here, in my courses folder, inside my workshops, basics folder inside here, if you open up this file, this markdown file inside here, there are going to be 3 steps to this particular task. The very first thing we're going to be doing is creating an issue inside GitLab. Remember, issues are the real starting place for pretty much everything. In this case, this particular issue is going to be to do with auto DevOps, which we'll come on to later. But we are going to create an issue. And then what we're going to do, and we'll come back to this and we'll have a play around once you've done it, is we're going to go into the world of our AI functionality. So we're going to be asking GitLab Duo, which is our AI tool, to various questions about things. And GitLab Duo behind the scenes will be using generative AI to give us a response to questions that we have. We also actually use our AI function inside here when we create our issue. So we'll be asking GitLab Duo. We'll then be working with boards with inside plan, so we can configure and create boards where we can place our issues into. And we'll also be looking at a concept of labels, where we can label pieces of work and use those labels as a placeholder on boards that we create. So as part of this task, what you're going to be doing is creating a board, adding a list into the board, and then finally at the very end of all of this, we're going to be doing we're going to be creating a merge request in preparation for the next phase of this. So what I'm going to do is let you loose on that over the next 5-10 minutes or so. And then we'll come back and have a bit of a recap of what you should have produced as part of this of this particular of these steps inside here. If anybody is struggling, please drop a comment in, and then we'll pick that up and we'll try and address it as we go through this. I understand some of you may have been struggling with the fork of the project at the beginning. I'm hoping that you've managed to get past that. If you haven't, just flag it in the chat, and then we'll help you out. Okay, everyone. So whilst you're doing that, I'm going to just drop into the project that I have. Here's one I made earlier. As you're going through that, folks, if you could, if you finish this step, and so we can gauge how quickly we're doing, if you could do a thumbs up if you finish that piece in the chat, and then we'll be able to understand what's going on. You would have seen a reference to Duo chat inside there, and the way we get to that is just via our help button in the bottom left. Duo chat is a tool that enables us to ask pretty much anything about the GitLab platform. So it tell me about, or what is an epic, for example. And then what this is doing, this is going off to Duo, which is trained on a number of different pieces of information, but primarily our documentation in this case. And this is just going to give you some information on what an epic is. And this is a really useful tool when we go through and use this. It's also, we can use it when we're writing code and writing tests and all that kind of stuff like that. We can use it to refactor, explain pieces of code, etc., as you will see later on part of your as part of your workshop. It's a really useful tool to use. It's a part of our Duo AI functionality. Well worth a look at if you get a chance. Okay. Yeah. So what I'll do, folks, so the instructions for what we have, we are in project management in GitLab. So yeah, so for those of you who haven't found the instructions, if we go into, just click into Tanuki Racing on the top left, you'll see inside this view here, this is our project, if you like. If we go into the courses folder, workshops, basics, and then this very first one here. So for those of you who haven't found those and I didn't make it clear, I apologize. And hopefully you're in there now. And the one that we're working on at the moment is project management in GitLab. If you're having trouble finding those, drop a note in comments and I will take you through that again. What we'll do now, we are coming up to 10 to, so I'm going to give this another 5 minutes or so, and then we will cover what we've just done, in the hope that all of you are up to speed and you're ready to move forward onto the next stage. Okay. There was a question around going into changing to plain text editor. So you can see Duo. I believe what you should be able to do with Duo is just select it from help here. In fact, this is when we create our issue. Add issues, generate want to okay. What we can do is new issue, and there is where's plain text editor mode. Yeah,
So you want to click that AI action button you were hovering over.
yeah. So there's an AI action inside here. There is, so if I just do like, you know, this issue, test issue, as an example, what we can do then here is in the bit where we create the description, I think inside here, it's going to be something like we want to auto DevOps our project, and then in fact it's on the AI thing, isn't it? It's on the Gen AI bit. Generate issue description. We want to use auto DevOps in this project, submit, etc. So that's what we need. So what this will see, I'm currently in plain text editing. If you were in rich text editing, you should have a button down there to switch to plain text editing. So you should be able to see inside the issue description a Gen AI a description provided by Duo. Yeah, and a point just made. I think there's in some issues. I think if you've never used plain text editing before, you can switch to plain text editing inside that box that I just showed you. So in my example here, in fact, if I just do issues, create new issue, I can change this to plain text editing down here. So I'm hoping that's not causing a problem for any of you right now. Let's give it another minute or so. Or more if you require. Let us know in the comments. Okay, so what we'll do, folks, we're gonna, as those of you who've completed this bit and they've done all the steps in that particular workshop for the plan section, could you please raise your thumb from inside Zoom? What I want to show you, we'll take a break at the hour for a few minutes. And then before then, what I want to do is show you what you should have done. So what we did, or what you should have done, is create an issue. The issue itself, remember, is where we start pretty much with everything. So in this case, this is enable auto DevOps. What happened here was when you created this, you used Duo AI to basically put in a bit of text saying that we want to auto DevOps this project. And this was generated for us by Duo. So this is a kind of, time-saving function inside here that we can use. And then this is the issue as it is. What we then went ahead and did is create an issue board. In fact, what we did before that is we created this label called in progress that I'm hoping that you've managed to produce. And then when we did, we moved this enable auto DevOps issue into this board here. And then, this is now automatically labeled as being in progress. And then at the end of all this, the next thing we did was create a merge request from the issue. So the use case or the flow here is that somebody's taken this piece of work on board. They've opened up a merge request. Under the covers within inside the Git world, that's going to create a feature branch, merge request branch. The work that we do is inside there. And inside that merge request, we can share and collaborate with folks within inside our team who are actually interested in this particular thing. So with inside our merge request here, when a pipeline ran, we'll come onto those later. And then we have the results of any kind of scans that happen inside the pipeline visible inside the merge request here. So what will be happening when we move on to our next step is to we're going to be making changes to this, and we're going to be making changes to the actual CI pipeline itself. So let's just take a bit of a break there. Let's pop up our next poll question in the meantime. So if that could be done now, please. If we have it. And the question is, where are you on your DevSecOps journey within inside your organization? Are you just starting out? Are you using CI? Are you testing on a per commit basis? Are you actually doing shifting left of testing? Are you using CD, etc.? Are you capturing and analyzing metrics as part of your development pipeline in interesting stuff around DevOps metrics, etc.? So be honest. Let us know where you're at so we can gauge what you're doing. Excuse me. And we're going to take a 10-minute break now, and we'll come back at 10 past the hour for the next bit. So that allows those of you who are running through this to catch up if you need to. Those of you who have ran through it, if you have got any questions, don't forget to put them in Q&A, and then we can field those and answer those as we go through. So I will see you all in 10 minutes. What's that? Okay, folks, let's just get another minute or so. I can reshare my screen. Let me, in the meantime, before we get started, folks, let me just give you the results of the poll that we did recently. So the poll that we had was all about whereabouts are you on your DevSecOps journey? So this is a question that we ask that enables us to kind of gauge where you are, what tools you're using, how advanced you are in some cases. And the categories were just starting, we're using CI, we're testing on a per commit basis, we're doing shift left testing, we're using CD, continuous delivery, and we are capturing and analyzing metrics to enable us to tweak our team and our performance. So the overriding response was that there are 73, put my camera back on, folks. Excuse me, 73% of you answered we are just starting. We are in the discovery phase of DevSecOps, which is interesting. So I'd be interested to know what kind of tools you're currently using, if any whatsoever. The next one was using CI. We are using continuous integration. So I suspect you may be using tools like Jenkins, etc. The finally down the bottom there, 1 out of 22 of you was we are using continuous delivery. The one at the bottom there was capturing and analyzing metrics, etc. That's more of the story around having a platform to measure things like how quickly are we picking up issues and are we working on those issues, getting them through into a useful environment where we can get feedback from, be it pre-production, production, or whatever. But before we move on to the next phase, what I'll do is I'll just share my screen. Bear with me for a second. And we will just cover off what we did in that last section. So share screen, share. So you should be able to see my screen. What you hopefully would have produced, he says, you would have, bear with me for a second, you would have created an issue inside here. The issue was called Enable Auto DevOps. There were some features on there, like a weighting that we put in. In fact, the weighting was 3. You assigned it to yourselves. You eventually got this label configured, this in progress label. We created an issue board inside here, and inside that issue board, we moved our enabled auto DevOps issue across into this in progress list here that we actually created. And then at the very end of all this, we created a merge request. So the merge request really is the bit where we're going to do our work. And inside this merge request here, we've got some other information which we'll see some more details on as we move forward. So I hope most, if not all of you, have managed to get up to that point. That really was a summary of our plan stage. This, as I mentioned before, is really great for project management functions. It allows us to configure users who are not really doing coding or anything, like deep in with a code base, or any, needs to change any files. They can come in and look at things like, our PM functions and our issues and our merge requests and labels that we've created. So really useful for that. It enables us to work as developers, as project management, as release, as operations. It enables us to work on this consistent single environment that we have, which enables us to put in things like, metrics, DevOps metrics, etc. So I'm going to leave it at that at this point, and I will be handing over to my esteemed colleague, Claire. Claire, would you like to take you forward?
For sure. Give me that screen share, Martin.
Thank you. Okay. So, can everyone see a screen that says deploying with CI/CD?
Yes.
Awesome. Okay, so we've now reached the portion in the agenda where we're going to go through the CI/CD part of the workshop. But first, we're going to do a little bit of a background on CI/CD within GitLab. And I'll also do a little bit of a general background on CI/CD, since we've got a lot of people that are sort of starting their journey. So CI/CD stands for continuous integration and continuous deployment, or continuous delivery. Continuous integration involves automatically building and testing your code changes as they're committed to your repository. And typically this can include compiling the code, running unit tests, and other automated checks to ensure the changes didn't introduce errors or regressions. Continuous deployment or continuous delivery focuses on automating the deployment process of code changes. Once code changes pass the CI phase and meet the predefined criteria, such as passing tests or code reviews, they are automatically or manually deployed to their specified environments. So the difference between continuous deployment in general is that this would automatically be deployed, versus continuous delivery still has a manual step of someone like hitting a button to do a deployment. To use CI/CD in GitLab, we use a YAML format file. This is at the root of your project, and it contains the configuration for your pipelines. Pipelines are declared as a series of jobs. A job is a single task within the pipeline, such as compiling code, running tests, or deploying. Each job is a distinct step in the pipeline process. So within job statements, we have things like script, before script, and after script. And these are important, especially when you have scripts that depend on each other. Script is the only required keyword in a job, and without it, a job wouldn't have anything to do. The before and after scripts are optional. They pretty much do exactly what they say. Before script runs before the script statement, but within the same shell. And its main purpose is to execute steps that are necessary in order for the script statement to run properly. After script runs after the script statement, and these are executed in a separate shell. The after script statement return code does not impact job success or failure. So some examples of like before script would be, you could use a before script to install AWS CLI with script, and then in script you would execute CLI commands. So, and then also like if you then created a job artifact, you might want to parse the results of the artifact after you're done in after script, or you could use after script like for cleanups. So within a pipeline, a job is only evaluated as pass or fail based on the exit code of the script statement. Now you might think this is all kind of intimidating, but the nice thing is we have things called templates within GitLab, which essentially serve as a mechanism for streamlining and standardizing your CI/CD capabilities across your organization. So this means that sharing and consuming CI/CD capabilities, both from pre-configured GitLab provided templates, say for example, we have like Android templates or Node.js application templates, and also sharing within your teams. Templates help foster collaboration and best practices disseminated throughout your organization, which is really at the heart of DevOps as well. So because, as we know, CI/CD is defined in YAML format. Templates are essentially just other YAML format GitLab files that we reference within our base GitLab YAML file that we use for CI/CD. Very similarly, we have components, and these are kind of, our next step after templates in trying to make this a very simple process to share configurations. Very similar to templates, but there are a couple differences. A component is a reusable single pipeline configuration unit, and they can be configured with input parameters for more dynamic behavior. They can also be released and used with specific versions. And instead of creating all your own components, you can also just search for published components that have functionality you need within something we have called the CI/CD catalog. So we are mainly going to be talking about auto DevOps, or we're going to be using auto DevOps in the lab today. GitLab CI/CD is incredibly feature-rich and powerful. You can do incredibly customized things, but for today, sometimes you just want to get going quickly without having to learn YAML at all first. So for this reason, GitLab built something called Auto DevOps. You simply switch it on, and Auto DevOps is going to recognize the programming language used in your source code. When it detects a supported language, it's going to build the pipeline accordingly, and this allows you to get started with a pipeline that builds, tests, deploys, and monitors your application for you with very minimal setup. We essentially recommend that people use this as a foundation and then customize. Like, this is very rarely going to be your end state for your production environments, but it's an excellent place to start out and build your customized configuration over time. So GitLab runners are essentially how we perform GitLab CI/CD. A runner is what makes running pipelines possible. There are a bunch of different types you can use, and they can be scoped on the project level, group level, and shared across an entire GitLab instance. The Q&A team are able to share links on the documentation if anyone indicates interest, but for now, we do not need to worry about the back end of what's happening with runners. As a note for today, there's a shared runner setup on the group that we're working on in the lab. So we're all sharing a fleet of runners. So bear in mind that if we all click that we want to start a job at the same time, there might be a slight delay that some of you experience as the runners are being allocated. Another quick note on runners and on this screen that we see here with all these different colored job statuses here. If a job is green, it means it has passed. If a job is orange, it means that it has failed, but the pipeline is fine to continue. And if a job is red, it has failed and the pipeline cannot continue. So for instance, you might have an orange job for some sort of test that doesn't really depend on anything else, but if your build isn't working, it's probably going to be red because you need the build for a lot of the future steps in your pipeline. If a job is blue, it means it's still running, so sit tight and just give it a little bit of time. Some of you may be familiar with Kubernetes, some of you may not. GitLab is very designed for Kubernetes. GitLab is vendor agnostic, so that means that there's a lot of different Kubernetes providers that you can use with GitLab. And our Kubernetes integrations allow you to leverage features like pull-based deployments, usage of our built-in container registry, canary deployments, and other deployment strategies, review applications, which essentially allow you to quickly see changes in a spun-up version of your app on your feature branch and are reflected in real time. And additional monitoring capabilities to help you stay online and up to date. So we're now going to enter the workshop portion of the CI/CD section. So in order to access the instructions for these, you want to go to your Tanuki Racing project. You want to go to courses. You want to go to workshops, basics, and deploying with CI/CD. I'm going to run through this first with everyone, and then I'll give everyone a little bit of time to work through it on their own, and then I might show specific sections again if people are having trouble. So the first thing we're going to want to do is you want to navigate to the left-hand build menu, and then you're going to go to pipeline editor. So this pipeline editor here is that GitLab CI YAML file that I was talking about earlier that you store at the root directory of your project. You'll notice that there's already stuff contained in here. So there's already some jobs defined. We're not actually going to use these. We're going to delete these because we're using Auto DevOps. And sorry, I'm just reading my own little instructions. Oh, sorry. First thing we want to do actually is you want to make sure you're not on your main branch. So if you happened to fork branches other than the main branch, you need to make sure that you are switching to the branch that is associated with the merge request you created in the last step. Hint, that is probably going to be one enable auto DevOps if you used the title auto DevOps for your issue, and if it's the first issue that you created. So I had the unsaved changes because I forgot about removing this. So I removed these because I'm on the different branch now. I delete all of the YAML code currently in the config. And then I should see. So then what I'm going to do is I copy the following code from the instructions into here. And what this does is it includes the template, which I spoke about earlier for Auto DevOps, as well as stages that we need or that we want to include. So what I really want you to focus on here is that we now see all of these other templates that are included as a result of adding Auto DevOps here. So if you wanted to look at what's happening in those templates, you could click in there, like maybe I want to see what's happening in browser performance, and I actually get a full copy of the that particular template there. So we've disabled the review app here, as is noted in the instructions, because we're not actually fully deploying out an application in this workshop. So you can also click on the Visualize tab that shows you what your pipeline is going to look like based on what we've configured. And then you can click on the Validate tab to validate that the pipeline is actually going to run successfully. Okay. So then we go back to edit. And I think we're going to commit our changes. Yeah. So before you commit, make sure that you are on your merge request branch and not on main. I'm going to commit my changes. And this is going to immediately kick off a new pipeline, which I can view if I go to build pipelines. I can click on the pipeline by going here and take a look at all the different jobs. As they execute, one of them or one or more of them should fail, and then I will show you something else. if anyone was watching and not executing their own lab, now is a really good time to execute some steps of the lab while we wait for this. Although actually, okay, so we have the code intelligence go check has failed. We click in here and I wanted to show one of the AI features we have at GitLab, which is root cause analysis. So essentially what this does is it tells us what it thinks the issue with the pipeline failing was. So one of the the reason this has failed is we don't actually have any Go code in our repository. Root cause analysis for smaller job logs like this, it might seem a little redundant because we can easily read through this, but sometimes job logs can be very, very long for very complex jobs. So it can be really helpful to have that root cause analysis to help you zero in on what the issue might be. So I'm now going to wait for a little bit. Maybe I can show specific sections if anyone is struggling with them before we move on to the next section. So just a reminder to find the instructions. If you go to Tanuki Racing, and then it's going to be one of the folders in the repository, and that folder is called Courses. Within that folder, you want to go to Workshops, and then you want to go to the Basics folder within Workshops, because we're doing the Basics lab. We've already completed the project management section with Martin, so now we've moved on to the deploying with CI/CD section. If you click into this document, you can see the instructions. I'll leave these on screen and sort of periodically move down on them. But because you have to copy and paste things in this section, I would recommend going and finding the instructions in your own lab. And then as you complete the work, if you can just post a thumbs up in the chat so I know how people are doing, that'd be really helpful. Thank you. So a reminder in this step where you're changing the code in your YAML file, or rather, deleting it and adding this section, you want to make sure you are not on your main branch and you are instead on the branch associated with the merge request we created with Martin earlier in the session. Yes, we're finishing at the pipeline, still running with a failure. I believe most of the jobs should complete other than that Go check job, which does not complete because there is no Go code in this repository. So you can also run the root cause analysis if you click on the failed code intelligence Go job. There should be a root cause analysis button, which we saw earlier. I'll just show you again. So this root cause analysis button, if you click into the failed job, you can then see the root cause analysis. Okay, I'm going to give like 3 more minutes and then we'll move on to the next section. Yeah, so like if we look at my pipeline right now, you can see that like, okay, so they're all finishing up now, but for a while they were running. Your build one will finish up first, then all the ones here, and then DAST will be last to finish up. And they might still be running, so that would mean they're in the blue state. You might have this failed job here, and then you might have some that are green. All right, and DAST failed, I think, because we've never set up an actual environment to do with this project. So don't worry about that. That's all fine. Okay, so let's move on to the next section then. We're now going to talk about security and compliance within GitLab and within GitLab CI/CD specifically. So we've just completed the deploying with CI/CD section of the workshop, and now we're moving on to enhancing secure. Oh, sorry, I didn't give 3 minutes. I'll wait a little bit more. Yeah, so the failed Go job is by design to show root cause analysis. And yeah, it's going to be asking you to create a Go file in your repository because it's saying there's no Go in this project, so we can't complete any testing on it. We do not need to complete that in this lab. The purpose of this failed job was just to show root cause analysis rather than actually going through fixing the job. Okay, I think I've waited around 3 minutes now, so we're going to move on to the enhancing security and compliance section. So why should you care about security and compliance? Cost of remediation is really, really high. You know, if you chuck code over the fence to production and it's blocked later by a security team, it can come all the way back and get put in the queue. And at that point, you can only hope that the people who wrote the code in the first place actually remember the context needed to fix the security vulnerabilities. Because this can happen sprints later when they get the ticket again. And if you view it this way, fixing bugs and remediation is really expensive, but we can make it cheaper by, bringing it left, shifting left, like we talk about. So if you want reports that these figures are based on, please ask in the chat. So shifting left essentially involves bringing security scans into your CI pipeline that we talked about earlier. The CI pipeline, if you remember, runs continuously through the development process. So your developers are getting frequent results from these security scans rather than getting results weeks or potentially months later. These are the security scanners that we offer within GitLab. I'm not going to go over all of them, but a couple that I wanted to highlight are our static analysis. So this essentially scans static code within your repository for known vulnerabilities. I also wanted to highlight fuzz testing. This is for checking inputting unexpected and malformed data into your applications to ensure that your response and stability remains normal in the face of unknown inputs. And then we also have dependency scanning, which is part of software composition analysis. And this analyzes external dependencies in libraries that you use within your code. The majority of our scanners are available on our free tier, with the exception of our DAST, fuzz testing, dependency, and license scanning. Okay. If it makes you feel any better about this stuff, because I know it can be intimidating, I don't fully understand all of the ins and outs of all of these scanners that we use, and I don't fully understand all of the results that we get either. But that's why we have ways to help within GitLab. For instance, we have something like GitLab Duo's Explain This Vulnerability feature, which is now in an experimental phase. And then also we focus on enablement for developers to ensure that they actually understand how to fix these vulnerabilities that they are faced with. When we talk about bringing in vulnerability scanners, oftentimes customers want to do this because they need to keep compliant with a certain compliance framework. So GitLab can help ensure compliance with a majority of regulations and standards, like the ones listed here. But we can also help to future-proof against changes and updates that may require more robust protections as regulations evolve. So GitLab helps users automate this compliance process, for instance, for the frameworks that are listed here, so they can avoid the manual work and focus on real actual innovation they want to do with their software by securing their software properly. The benefits of compliance within GitLab. You can leverage compliance pipelines, compliance framework, project templates and labels, and compliance automation, all to help you achieve these goals. We're not going to be talking about these specific features in this workshop, but if you have any interest in these features or in our compliance suite of features, please drop a message in the chat and we can share some further documentation with you. At this time, I'd like to stop for the third question, if we're able to pop that up. Okay, so we've had everyone answer the poll. It sounds like we should bring the pace a little bit slower, so I'll try and go quite slow through this section. Yeah. Okay, so we're now going to return to our GitLab Learn Labs. We want to look at the third set of instructions. So to look at those, if you remember, you're going to go to your project, which is Tanuki Racing, not your test group, your project. You're going to go into courses, which is a folder in your repository. You're going to go to workshops, which is a subfolder within the courses folder. And then you're going to go to the basics folder, which is a subfolder within the workshops folder. You're then going to click on enhancing security and compliance. I'll give everyone a little bit of time to complete that. And then I will go through the lab to show people what they should be completing. So the first step we want to follow is you want to go to the merge request that we already created. I'm going to do that by going to merge requests here on my left panel. And I'm going to click on resolve enable auto DevOps. Your merge request should probably be called something similar or something exactly the same. What we want to focus on here is this widget where we have our license compliance and security scanning results being created. So from here, we can look at our security scanning widget. We can click on a vulnerability to learn more about it. And then we can, as it says to do in the lab, dismiss a vulnerability with a comment. False positive. Obviously, this isn't actually a false positive, but I'm just showing an example, comment, and reason for dismissal. Probably also didn't need the comment there. So I'll confirm this is a dismissal. Just as an example of how you can interact with the vulnerabilities on a merge request in GitLab. So these vulnerabilities currently exist in our base code base. We haven't introduced them with the merge request. They're showing up here because this is the first time that we've run scans on this code base. What we're now going to do is merge this into our main branch so that all future merge requests that are created will already have these scanning jobs attached to their CI process. So we'll already have these scans ready to go. So what you're going to do is scroll down on your merge request, click merge. You can delete the source branch. It doesn't really matter. And once you merge, a GitLab pipeline is going to be kicked off for your main branch. We can see this if we go to build pipelines. So as you can see here, I have a pipeline running for my main branch for auto DevOps. I'm now going to let this finish for me because I need it to finish to look at the next step. I suggest that everyone work through this first step in the Learn Lab, so I'll show it again. We're going to Tanuki Racing, Courses, Workshops, Basics, Enhancing Security and Compliance, and we're working on step 1 right now. You want to get to the point that your merge request has been merged into main and you have a pipeline for main running. Then we're going to move on to step 2. I'll wait a couple minutes. So I see a question about deleting the main branch. It would not have said to delete the main branch. It's asking if we want to delete the branch associated with the merge request. So I recommend that you complete step 1 now because we need to have the pipeline from step 1 run before we can look at step 2. So I'm just going to check my pipeline now. Still running. Give it a little bit more time. As I mentioned in the runner section, because we're using a shared runner for this group, and a bunch of us have just kicked off pipelines with a bunch of jobs, there might be some queuing happening for jobs. Mm-hmm. So just once again on the instructions for where to find this part 1 that I've just completed. If you go to your Tanuki Racing project, so not your test group, the project that we forked, you can go to courses, which is a folder within the repository. Then you go to workshops, which is in a folder within the folder within repository. And then you go to basics. And we are on step 3, enhancing security and compliance. Once you click on that, we are completing step 1, merge request security results. All right, I think my pipeline should be almost complete. If you're looking for where to find the information described in step 1, you're going to find that on a merge request. The merge request you created in the first part of our lab with Martin. So I've already merged mine, but if you go to merge requests on the left side of the screen, you will see an open merge request. Again, mine is merged. That's called resolve enable auto DevOps, assuming you completed step 1 with Martin. When I say step 1, I mean the project management section of the lab. Okay. All right, it looks like my pipeline has completed. This all makes sense. The code intelligence go will fail because we have no go code in the merge request. And dash fails because we haven't connected any sort of environment for it to attach to. So now what we want to do is we want to check out our security dashboard to see an overview of all of the security findings we've just gotten. What we're going to do is we're going to go to Secure, Security Dashboard. And we can see that we've added a number of vulnerabilities to our code base just now. That's because this is the first time we've run scans on these code. Okay, and now we want to look at something called the vulnerability report. And just to be clear, we've now moved on to step 2 of the security and compliance section. This step is titled merge request security results. So I'm going to go to secure vulnerability report. And from here, I can look at the vulnerabilities associated with the default branch on my repository. Let's take a look at one of these. Let's see, what does it want to look at? A SQL injection? I might not have one of these. Anyway, let's look for a fast one. There we are. We want this SQL injection. So I'm going to click on this. And I get a little bit more information about this vulnerability here. As I mentioned earlier with Explain This Vulnerability, we have this AI feature that we essentially can send a minimal prompt to the AI with the vulnerable code. So we're just sending this one line here. And we get an explanation, an example of what an attack might look like, as well as our recommended fix for how to prevent the vulnerability. This is still in the experimental or the beta phase right now, but this is something that I think is going to become really exciting, especially when we talk about enabling developers to actually fix the vulnerabilities for the security scanners that they're working with. Okay, we did the explain this functionality. And we see the recommended fix. So we also see that we can actually get into the file that has the specific issue. It highlights where the issue is. And then you can, oh, sorry. You can go to your Duo chat that Martin talked about earlier. And you can ask it something like, what does this code mean? So to be clear, what I did to access this is I've gone to the file associated with the SQL injection vulnerability that we looked at. I've clicked on the line associated with the vulnerability. I've then gone to the bottom left-hand corner of my screen and selected GitLab Duo Chat, which pops up Duo Chat over here. And then when I went back and highlighted this line with Duo Chat open, I think it doesn't want to do it again because it's open, but you should see a little bubble pop up that says explain this line. Anyway, I'm gonna just pop back to the merge request widget right now because it looks like some people were still having issues with that. So if you go to merge requests, merged, resolve, enable auto DevOps, which should be a similar name for yours. The widget that we're talking about looking at in here is this one right here that's loading. So you should see a license compliance, code quality, and security scanning section. The security scanning section might take a little bit to load because it does have a lot of results in it. So you should see no changes with code quality because we haven't actually altered any code. But you should see a number of findings on the security section of the tab because these are the first times that we've run these security scanners in this project. So if you wanted to check out one further, you could then click on it here, find out a little bit more. Like I showed earlier, you can go to the actual section that's vulnerable within your file, go to Duo Chat, and ask for explain. But it looks as though explain is not behaving right now, but it is a beta feature. So they might just be changing something around right now. Okay. I'll give everyone a couple minutes to complete that. If you have any questions on what we went over in that section, do let the Q&A staff know. If you go to Tanuki Racing, once again, just to show courses, workshops, basics, enhancing security and compliance, we are currently on step 2, merge request security results. That's what I've just shown you right now. For finding the SQL injection vulnerability, let's go back to looking at the vulnerability report. So because the SQL injection vulnerability is a medium vulnerability, it's not going to show up on the top of the list when you have no filtration options going. So what you want to do is filter by tool, and you want to select SAST. And then that SAST job, you should just have the one that's the possible SQL injection. I'm going to move on to the next section in about a minute. Okay, I'm gonna start moving on to the next step in the process. So that's gonna be step 3, review and download SBOM report. So what we're going to do, so I guess first off, some background. An SBOM report is generally associated with software composition analysis and by extension, dependency scanning and license scanning. This becomes very important for compliance reasons for a lot of various compliance frameworks, as well just general governance. It can be very useful to know where in your code different dependencies are being used. So within GitLab, we can see this by going to secure dependency list. And this dependency list is generated from a combination of our dependency scanning and our container scanning. This can be viewed at a project, a subgroup, or a group level. So if you click through a few of the pages, you notice that the components are all directly or indirectly, either via transitive inclusion, included in your project. And we can actually export these findings in Cyclone DX format. Oh, okay, actually it wants us to do the pipeline version of it. So what we'll do is we'll go to build pipelines. And then, oh, sorry folks, I'm being bad at reading my own instructions. So then you can download a specific artifact associated with a pipeline, and you could download Cyclone DX in this case. So to be clear, what I showed earlier is also useful where you download straight from the dependency list, but that download would give you a current state of your application from the last ran pipeline. Rather, this way allows you to download SBOMs associated with previous pipelines that you've run, even if they might not be the most recent one. So, yeah, this essentially becomes very helpful, especially when we think about like the log4j vulnerability that has happened in the past. Oftentimes when I show this feature to people, they think about how much easier that situation would have been had they had the GitLab dependency list set up. I'm going to give everyone a couple minutes to complete this section, and then I'm going to move on to step 4, the license compliance section. Okay, so the next section we're going to be working on is from the same workshop that we've been looking at. So it's in the courses, workshops, basics folder, enhancing security and compliance. And we are now going to look at step 4, license compliance. This is the last step in our workshop. Bear with me, folks. Okay, so license compliance goes somewhat hand in hand with dependency scanning. They work in tandem and in fact use the same scanner on the GitLab side. So in order to look at the license compliance, what we're going to do is you're going to go to secure license compliance. And we can see all of the different licenses detected on the project. Now, what if we don't want to allow MIT licenses anymore? Well, we have governance features within GitLab that can help also with compliance, called scan execution policies. In order to access these, what I'm going to do is go to secure policies, and I'm going to create a new policy. Oh, sorry, we want a scan result policy, not a scan, or merge request approval policy. These have recently had their names changed. So we're going to be creating a merge request approval policy. We're going to select the policy. We're going to call it deny MIT license. We're going to select that it's enabled. And we're going to set that if a license scan, I think we want on protected branches, yeah, but doesn't necessarily matter for the purposes of just showing it here. With no exceptions, and the status is we want both newly detected and pre-existing MIT licenses to be caught, and if the license is matching MIT, let's see, there we go. So if this happens, we want to ensure that Logan is the only person able to approve this. So essentially what this means is this is quite granular controls for setting when merge requests should be blocked for your developers. This becomes really important when we talk about spreading out maybe your license team or your security team's time properly. So they shouldn't be looking at every single result of your of your security scanners found. They should be focusing their efforts on the things that really matter to them. So if you want to look for specifically the MIT license, I had to scroll down a little bit. If I type MIT here, it's like 8th on the list or something. But again, for our purposes, it's more about just demonstrating that you can select various licenses from our set to use. Okay, so we're now going to configure with a merge request, and this is going to merge into something called an associated security policy project. So you'll see now that I have something called Tanuki Racing Security Policy Project. This might seem confusing at first, but there's a very important reason that we do this. And this is because a developer might not necessarily have permissions in a security policy project elevated to the same level that they might in a regular project. In a regular project, you want your developers to be able to go in and make changes to the CI/CD file that you've defined in your root directory. If you are defining things with a scan result or with a merge request result policy or a scan execution policy, and these are made in these associated security policy projects, you can make it so developers do not have permission to go and turn off anything from here. So this becomes important for compliance when you need to prove to your auditors, we have been running the scans that we say we've been running this entire time, and we have not been allowing any sort of vulnerabilities or licenses from this, and this to enter our code base, and we can prove it because no developer can turn these off. Okay, my code is ready to merge, so I'm going to go ahead and click merge there. Okay, once this has been merged in, we now need to go back to our original Tanuki Racing project. So we're going to need to follow the breadcrumbs to do that. We're going to need to go to your test group and then click Tanuki Racing here. Now, if we run a new pipeline for a merge request, so let's maybe just create a new merge request. So what you can do is new branch. I'm just going to call this test branch, or let's call it merge request policy branch. And then if I create a merge request from here, sorry, I'm going through this a little quickly. I'll go slower again a second time. I want to kick off a pipeline associated with this branch, which it has done. And then we should see, now that we have denied this MIT license, we should see on this screen, once the pipeline has completed, a policy denying us the ability to merge our merge request. We should probably add some actual code to our merge request. That might matter. Then just commit to merge request policy. And then go away. Sorry. There we are. So I may have just kicked off another pipeline, which isn't good. Okay, so the pipeline's still running, but we can see the effects of deny MIT license that we created. And we can see that Logan Stucker is required to approve this before I could possibly merge this code forward. So reiterating what I said again, it becomes really important because the developers, they're not necessarily the ones having to make this call of like, ooh, is this a case where I can merge this into production? They work in tandem with your security teams and your legal teams to determine what the correct way to move forward should be. Okay, I'll let people work through that a little bit on their own. And then that will conclude the lab portion of the project. And then I'm just going to show you how to transfer the project back to your namespace so that you can keep this for future reference if you'd like. So I'll give everyone a little bit of time. I'm going to go back to the instructions briefly. And once you're done, just drop a thumbs up in the chat so we can see where everyone's at. So just gonna work through the steps of step 4 a little bit again. So we're creating a policy, which can be done from secure policies. You're then gonna create new policy in the top right-hand corner, and you're gonna create a merge request approval policy. At that point, when you add all the things and configure with a merge request, you're gonna get taken to an associated project called Tanuki Racing Policy Project, I think. And you are going to merge that change into that policy project. At that point, you need to go back to your original Tanuki Racing project. I usually accomplish this by going to my test group and then clicking Tanuki Racing from there. And then we can see the effects of the policy by creating a new merge request and looking at what happens on there. I can repeat that again if people need. But for now, I will go back to the instructions. Yeah, so for those of you that may have accidentally clicked a scan execution policy, what a scan execution policy does is it defines rules for when you should always run scans. So normally I might, as a developer, choose to define secret detection within my general GitLab CI file. But as a developer, I can then turn secret detection off. So if for compliance reasons you need secret detection, a scan execution policy can be a very good way to ensure that you are always running secret detection and that developers cannot turn it off at whim. Okay, can I get if anyone's having trouble right now, do mention it in the Q&A. Otherwise, I'm going to move on to the next section and we'll move on to doing sort of a live Q&A. So just to touch briefly on this, I'm not going to actually show you how to transfer your project, but this lab will become unavailable, I believe, in maybe a week, maybe a couple days. And you might want to transfer your project here into your regular namespace so that you can look at the result, just keep the results. If you don't have a GitLab Ultimate subscription, though, a lot of these features might not be available for you when you transfer the project. If you choose to transfer the project, if you just Google transfer project GitLab, these instructions will come up. You just need to follow these steps and you'll be able to transfer it into your own namespace. Okay, I'm now going to pass back to Martin for the conclusion.